Okay, welcome back. And as promised, I'm gonna teach you how to convert Fischer projection to condensed line structure. Now we've saw the full skeletal structure, and then we saw the condensed line structures. Now this is another way of writing a condensed line structure, but in a straight line, almost a straight line that everything is kind of branching to the left and the right. Now, I don't know if I'll have you draw this one. I probably will give you this one because that's the whole purpose of this exercise is, right? Now, first, whenever you want to convert Fischer projection to condensed line structures, okay, first you got to figure out how many carbons does your molecule has. Now, this is not necessarily the numbering for naming, because this is just to figure out how many do you have. So that's 1, 2, 3, 4, 5, and 6. Okay, right? So this is all carbon, 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 right? So there's a total of 6 carbons, right? Okay, so let's go back and get rid of all this information and write at the very top 6 carbons total. Okay. Good. Now the next thing is, what we are generally going to do is first always assign the wedge to the group that's at the very top, and then to the group that's at the very bottom. Okay, right? And then we are going to get a different color, perhaps maybe a blue. Okay, and then give these closed wedges. I call the other one open wedges, and these I call them closed wedges. This is typically the trend you would follow. So this is closed wedges for all of them. Don't worry about the groups themselves, just assign them closed wedges. I call these closed wedges, the one with the shaded portion, and the one with one above, as in pink above, I call them open wedges. Okay, so look like a bow tie, a bunch of bow ties. Okay, all right, so now just looking at it visually, you're going to assign R and S for each of these carbons. Why can't we assign R for this? Because a carbon containing a double bond can never have R or S, or it can never be chiral, so it has to be chiral first for it to be R and S. So this is out of question. So is this, because this carbon is attached to 2 hydrogens and the OH and then this whole thing. So this contains 2 hydrogens, so this is not chiral. So the rest of them are all chiral, so I'm going to give them a different color. So this is all chiral. If you want to know why I think chiral, you already know the answer, how to figure out chirality. This is attached to a hydrogen, OH, this whole big group, and then this group at the top. Right, now assign going to priority, right? Now this carbon right here, I'm going to put this dot for carbon, right? It's attached to an oxygen directly. It's attached to a carbon and an oxygen, and a carbon and oxygen and a whole bunch of them, and then it's got a carbon double bond O and a hydrogen, right? So even though that means they're both attached to a carbon and an oxygen, carbon and an oxygen, right? But this is a double bond, right? So that gets priority. So this would be number 1, this would be 2, this would be 3, this whole thing is 3, and that's 4, right? So that means it'll be 1, 2, 3, right? That is counterclockwise, right? Counterclockwise, and it's on the back, right? The hydrogen is in the back, right? So what does that mean for us? For our counterclockwise, back is S. So is S, right? So I am going to go back and get rid of everything like everything I've drawn, like 1, 2, 3, etc., etc. Okay, so this is S, right? Now let me refocus on why I gave this number 2 and this number 3. This carbon is in turn attached to a carbon, but this carbon is attached to a double bond O, okay? This carbon is also attached to OH, but then first it's attached to this carbon before it's attached to an oxygen. That's why this got the priority, because oxygen is higher than carbon when they're competing, okay? Let's do the same for here. So this gets number 1 priority because it's directly attached. And then we have a carbon attached to a carbon attached to a double bond O, carbon attached to a carbon attached to a single bond O. So this is 2, and this is 3. This whole thing is 3, and this is 4. So again, 1, 2, 3 clockwise, and then in the front, right? Clockwise front. Clockwise front is S. So this is also S. So let's go back. Okay, this is S, right? Okay, now let's do the same here. So this, from here, it's quite straightforward. This is 1. Clearly, this is number 2 because it contains carbon and oxygen, but then it contains carbon and oxygen. So this is bulky now, so it's 2. This is 3, and this is 4, right? So it's 1, 2, 3. That's counterclockwise and front. Counterclockwise and front is R. So let's go back. This is R. And let's do the last one. 1. Clearly, this is going to win the race for 2. This is 3. And this is 4. So it'll be 1, 2, 3. Again, counterclockwise and front. Let's get rid of all this. Counterclockwise and front is R again. So that's it. So we have, if you had to start numbering, you would always start from here because this has a double bond on the carbon. So 1, 2, 3. So it'll be, so S, S, R, R, right? How do we draw the line structure? Well, we're going to do some guesswork here, but then what we're going to do is, let's start here like this. Hydrogen, double bond O, okay? That is the carbon that's attached to this carbon, which contains, let's go draw all the carbons out first. Okay, we got 4 carbons, and then this ends up at CH2OH. Okay, so these are the 4 carbons. Let's for now write, I'll teach you an easier way, okay? Pick, we have HOH, HH on one side and OH, OH on the other side, right? Pick one side to be all away and pick one side to be all towards you. Okay, it doesn't matter which one you pick, but be consistent. So what I'm gonna do is, I'm gonna consider all this to be away. Okay. Okay, and I'm gonna keep all this towards me. So when I go write it, I'm gonna write my hydrogen and OH this way. Doesn't matter whether you write above or below, just a matter of preference. I'm just gonna, again, keep the OH and hydrogen, and then again, hydrogen. As I said, I'm gonna keep all this away and all this in front towards me, okay? So I'm being consistent with what I wrote, okay? Okay. Now let's go assign priority to see if we get this right. Okay, so this is 1, this is obviously 2, this is 3, and this is 4. Okay, so that'll be 1, 2, 3, right? That's still clockwise, right? That's clockwise, and hydrogen is in the front. So let's go get our table, and clockwise front is S. So this is S. Okay, so let me go get rid of all the 1, 2, 3, 4s and just write the S alone there. S. Okay, this is a concept that you may have to practice multiple times. Despite the fact I've made it so easy for you with this approach, you're not going to get it wrong. All right, it may be a little tricky because you've not seen these concepts before, but you've seen how to assign R and S before, so should be good. All right, we got one down. So this matches that. Very good. Let's go to this one. This again is 1, right? And this is 2. Why? Because this is attached to carbon. It's attached to a double bond O. It's attached to a carbon, attached to a carbon. And this is just OH on both sides. So this is exactly the same, but this is where the difference happens on the third carbon, right? So that is going to be number 2. This is 3. And this is 4, right? Very good. So that'll be 1, 2, 3. Again, this is counterclockwise and hydrogen is in the back, right? So counterclockwise back is S again. So that's good. So let me go ahead and get rid of everything back. So this is S as well. Okay, so we seem to be doing fine. And let's go do this one. So this is 1. This obviously is number 2 because it contains the C double bond O. This is number 3. This is number 4. Connect 1, 2, 3. That has to be counterclockwise, and hydrogen is in the front. So counterclockwise front is R. Very good. So let's go back, get rid of all this, and just write the letter. This is R. Oh, I went to this, so I forgot this one. So it's okay, we can still come back to it. So this is 1. This is obviously number 2. This is 3. This is 4. You see how clinical and systematical I'm approaching this? Only if you do this, if you do it erratically, make a lot of guesses or try to cut it short, you're not going to, okay? 1, 2, 3, that's clockwise, and hydrogen is in the front, right? So what does that mean? Clockwise front is S, right? Right? Clockwise front is S, right? This one is telling me, according to the table, this is 1, 2, 3, clockwise, and front is S. So let's go get rid of all this and write S. But what do we need? Don't we need this to be R, right? Because it matches SSR. 3 things matches, 1 doesn't match. What do we have to do is, well, you don't need to redo the whole molecule. I'm going to do this exactly in black and change where the change needs to happen. Most of you probably already guessed it, what I'm going to do. If you did, kudos to you. It means you got the concept. You don't need my answer. You have already written the answer on your own, okay? I am not making any changes to anywhere we got it right, okay? I'm gonna leave this one alone for a second. I'm gonna finish the rest. So this is the only problem that's gonna take you the longest time, probably in the entire course, okay? So if you see this problem on the test, reserve it for last and just approach it to the very, very end, okay? Now again, what I'm gonna do is assign this alone a different color because see, that's the abnormality. We should have got R here. So all I'm gonna do is flip this to a hydrogen and flip this to my OH. Let's see what happens now. That'll change a lot of things, all right? So let's get a different color. So this is 1, this is 2, this is obviously 3. This whole thing is 3, right? Oh, sorry. I made a mistake earlier. So let me. Okay. If no one spotted me, I would have probably, I mean, I would have figured it out myself. That CH2OH should have been here. I apologize for that. Okay. Because all of a sudden the molecule looks so much different. So as I said, all I have to do now is keep in mind, if this is R, if I flip these two, I'm going to get R, okay? Because this is S. If I flip these two, I'm going to get R. I should, theoretically speaking. So let's go assign priorities. Let's get a different color. So this would be 1. This would be 2. This whole thing would be 3. This would be 4. So 1, 2, 3, that's clockwise, but the hydrogen is in the back. So that means clockwise back should be R. Bingo. So let's go get rid of all this and leave just that. All right, so R. Now if you notice, I have retained SS or R. Now you may have to do it more than once. Again, I did not do this problem ahead of time, so I always flip it. I always keep the left side as pointing towards me and the right as pointing away from me. That's just the way I have done it, and then I make changes as needed. All right, so don't pick half and half. Always pick one side completely as towards you and one away from you. Work it out, okay? Work it out for the actual Fischer projection before you even work the line structure, okay? I have done it systematically here. I don't need to do another compound for this. This is comprehensive as it is. And I picked a 6-carbon compound, okay? That's long, all right? So I don't need to do another version of this. You have to first watch this and understand and write down, what is that I don't understand? What part of it? Do I not understand the entire video? That's a fair enough thought in your mind. Oh, I don't understand just the last part. I don't understand the middle part. I don't understand the first part. You have to know which part you don't understand, okay? If you don't understand the entire video, my first recommendation would be go back and watch it again. Write down, don't just watch it 10 times, okay? At least at one point in time, you should write down your understanding of or what you don't understand. You should do one or the other, okay? You should write down at least what you understand or what you don't understand. You can't just keep watching the video because that's not going to really help. Okay, now as I said, I worked the most difficult one of the bunch because, you know, if you understand this, then you can literally transfer any Fischer projection into a condensed line structure with appropriate R and S notations. Okay, all right, so that's it for Fischer projection and condensed line structure. The next video that I post will be on converting Newman projections to condensed line structures. Okay, and that's pretty much all I have to say for this video. So stay tuned for the Newman to condensed line structure video. Okay, bye-bye.